All right, jumping right in. Today's deep dive is something crucial, but, often overlooked. Industrial Control System Security. ICS, for short.
Right.
We're talking systems that keep the lights on,
Yeah.
the water running,
Yeah.
factories humming,
Yeah.
all the stuff we kind of take for granted.
Absolutely. Until it goes wrong.
Until it goes wrong, yeah.
Yeah. And that's what's so fascinating about this.
Right?
Most people, they don't realize how much we depend on these systems every single day.
Yeah.
Like, they're the silent heroes of our modern world, really, working behind the scenes.
Yeah, for sure.
Keeping everything running smoothly.
You sent over some seriously interesting material.
I did.
And it's clear you want to go beyond just knowing what ICS is. You want to understand why it matters.
Absolutely.
Right?
Yeah.
And how it's a whole different ballgame compared to, say, worrying about someone hacking your email.
Exactly. And recent events really highlight why this is so timely, right? I mean, remember that attack on the water facility in Florida?
Oh, yeah.
Or the one that targeted the gas pipeline in Georgia?
Yeah.
Those weren't just isolated incidents. They were wake-up calls, really.
Definitely.
About how vulnerable these systems can be.
Yeah, those definitely got my attention.
Yeah.
So to kick things off, can you give us a quick breakdown of what ICS is exactly and why we should care?
Sure. At its core, ICS is all about managing industrial processes. Things like power generation, water treatment, manufacturing, really anything that involves physical equipment, automated control. They use sensors to gather data, compare it to set points, and then make real-time adjustments to ensure everything runs smoothly and safely.
So it's like the brains behind the operation.
Yeah.
Making sure everything's running as it should.
Exactly.
But honestly, why should the average person care about this? Is this really something I need to worry about?
Well, think about it this way. What happens if your power goes out?
Yeah.
For an extended period?
Yeah, that's not good.
Or if your water supply is contaminated?
No, that's definitely not good.
These aren't just inconveniences.
Right.
They can have a massive impact on our daily lives. ICS underpins our entire modern infrastructure.
I see.
When these systems fail, the consequences can cascade through everything.
Wow.
Healthcare to transportation to the economy as a whole.
Okay. I'm starting to see why this matters.
Yeah.
But you mentioned earlier that ICS security is different
Yes.
from, say, traditional IT security.
Yes, it is.
What makes it so unique?
Well, it's a whole different beast.
Okay.
Traditional IT security often focuses on protecting data, confidentiality, things like that. But with ICS, safety and availability are paramount.
So it's not just about someone stealing data. It's about someone messing with the actual physical process.
Exactly. Let's take the example of a power plant.
Okay.
In a typical IT environment, a glitch might mean your computer crashes and you reboot. In a power plant controlled by ICS, a similar glitch could cause a sudden shutdown, plunging entire cities into darkness.
That makes the stakes way higher, for sure.
Absolutely.
So how do we even approach securing these systems when the consequences of failure are so serious?
Well, there are frameworks and guidelines, thankfully.
Okay.
One of the most widely recognized is the NIST Guide to Industrial Control System Security.
Okay.
It breaks down the complexities of ICS security into manageable pieces.
So this guide outlines some specific objectives for securing these systems, right?
Yes. 6 main objectives, to be exact.
6, okay.
These are kind of like the pillars of ICS security. We have restricting logical access, restricting physical access, securing individual components, protecting against data changes, designing for redundancy, and incident response planning.
All right, let's unpack those a bit.
Okay.
What does it mean to restrict logical access in the world of ICS?
Think of it like this. Imagine your ICS network as a medieval castle. Restricting logical access is like building a moat and drawbridge around it, using firewalls and other security measures to carefully control who gets in and what they can do once they're inside.
So it's about creating layers of defense.
Right.
To keep unauthorized users out.
Yes.
Of those critical systems.
Exactly.
What about restricting physical access?
Yeah.
Is that as simple as putting a lock on the door?
It's certainly a part of it, but it's much more than that. Remember the pipeline attack we mentioned earlier?
Yeah.
One of the vulnerabilities they exploited was, in fact, physical access.
Oh, wow.
So we're talking about security guards, fences, surveillance systems.
Okay.
A multi-layered approach, really,
Right.
to safeguarding the physical infrastructure itself.
It sounds like you can't just focus on the digital side of things. The real world is just as important when it comes to ICS.
Absolutely. And it's not just about keeping bad guys out.
Right.
We also need to think about insider threats, like disgruntled employees who might have legitimate access.
That's a good point.
Yeah.
It's not always about some shadowy hacker. It could be someone you work with every day.
Right.
So how do you secure individual components within an ICS? Is it similar to what we do with our personal computers?
There are definitely some parallels.
Okay.
Just like you'd install antivirus software and keep your operating system updated.
Right.
We need to harden those ICS devices. That means applying security patches religiously, disabling any unnecessary ports or services,
Right.
and using really strong passwords.
Like locking down all the doors and windows in your house, right? Making it as hard as possible for someone to break in.
Exactly.
What about protecting against data changes? Why is that so crucial in an ICS environment?
Because in an ICS, data isn't just information.
Right.
It's instructions.
Oh.
Imagine someone tampering with sensor readings in a water treatment plant. That could lead to contaminated water being pumped into the system,
Wow.
potentially harming thousands of people.
Okay, now that's scary.
Yeah.
It's not just about stealing data. It's about manipulating it
Right.
to cause real-world chaos.
Exactly. So we use things like encryption, digital signatures, and access controls to protect data both while it's being transmitted across the network and when it's stored on devices.
So it's like a digital chain of custody,
Yeah.
making sure the data is authentic and hasn't been tampered with.
Precisely. And then we have designing for redundancy. This one's all about making sure that if one part of the system fails, there's a backup ready to kick in.
Okay.
Think of it like having a spare tire in your car.
Right.
You hope you never need it, but it's essential to have it just in case.
Makes sense. So if one component goes down, you don't have a complete system meltdown. But doesn't having more components mean you have more things to secure?
Right.
More points of vulnerability?
That's a great point, and it's something we have to carefully consider.
Yeah.
But the potential consequences of a single point of failure in a critical system can be catastrophic.
Right.
The benefits of redundancy usually outweigh the risks, especially when you layer in all those other security measures we've been talking about.
All right, see the logic there. And that brings us to our final objective, incident response planning.
Yeah.
I know you mentioned this earlier, but why is it so important in the context of ICS security?
Imagine a fire breaks out in your house. You wouldn't just stand there and watch.
Right.
You'd have a plan,
Right.
right? Call the fire department, evacuate, grab the fire extinguisher. Incident response planning for ICS is like that fire drill.
Right.
But for cyber attacks or system failures.
So it's not just about preventing attacks.
Right.
It's about knowing what to do if something actually happened.
Exactly. It's about having a playbook ready to go.
Okay.
Who does what, how you communicate, what steps you take to contain the damage,
Right.
and get things back online safely. And just like with a fire drill, you have to practice and make sure everyone knows their role.
Wow, we've covered a lot of ground here.
We have.
And it's clear that ICS security is way more than just a technical issue. It's about people, processes,
It is.
and understanding the potential impact on the real world.
It truly is. And we've only scratched the surface. There's so much more to explore.
Yeah, I'm ready for part 2.
Okay, great. Welcome back to our deep dive into the world of industrial control system security.
Yeah, it's fascinating stuff, honestly.
It is.
Like this whole hidden world that's running beneath the surface
Right.
of everything we do.
Absolutely.
But those NIST objectives, those really drove home.
They did.
How different this is from typical IT security.
Yes.
The stakes are just so much higher when you're dealing with these systems.
Yeah,
The
absolutely.
controlled, like, power grids and water treatment plants.
And that's why in this part I thought we could get a
Right.
bit more into the nitty-gritty.
Okay.
Let's explore some of the specific technologies and strategies that are used to safeguard these critical systems.
I'm ready to roll up my sleeves and get technical. Let's start with that first objective
Okay.
discussed. Restricting logical access.
Right.
What are some of the tools in the ICS security toolbox that help us do that?
One common approach is network segmentation.
Okay.
Imagine dividing your network into smaller, more manageable chunks.
Okay.
Almost like creating separate rooms in a house.
Okay.
We use firewalls
Right.
and virtual local area networks or VLANs to create these compartments.
So if someone manages to breach one part of the network,
Right.
it doesn't give them automatic access to everything else.
Exactly. It helps contain the damage,
Right.
prevents an attacker from moving laterally.
Okay.
Throughout the entire system, it's a fundamental principle in ICS security,
Yeah.
limiting the blast radius
Right.
of a potential attack.
That makes a lot of sense.
Yeah.
What else do we have?
Well, just like you'd have security cameras
Right.
and motion detectors in your home,
Mm-hmm.
we have intrusion detection and prevention systems, or IDPS,
Right.
in the ICS world. These systems constantly monitor network traffic, looking for any suspicious activity that might indicate an attack.
So it's like having a 247 security guard
Yeah.
patrolling the network,
Yeah.
watching for any signs of trouble.
Right.
And if something does happen, what then?
That depends on how the IDPS is configured.
Okay.
It might simply log the event and alert security personnel, or it might take immediate action to block the suspicious activity. It's like having that security guard call for backup.
Right.
Or even intervene directly to stop an intruder.
That's reassuring. Are there any other tools
Oh, absolutely.
in this logical access arsenal
Yeah.
we should be aware of?
One that's become really important, especially with the rise of remote access and cloud-connected systems, is multi-factor authentication.
Oh, yeah. I use that for my banking and email.
Right.
It's where you need something in addition to your password, like a code from your phone
Yes.
or a fingerprint scan.
Precisely. In the ICS world, this extra layer of security can be a real game changer. It makes it much harder for attackers to gain access,
Oh.
even if they manage to steal a password.
So we're talking about firewalls, intrusion detection, multi-factor authentication.
Right.
All these different layers working together to keep those critical systems safe.
It's all about creating a defense-in-depth approach.
Okay.
And that brings us to our next objective, restricting physical access.
Right. We talked earlier about how physical security can be just as important as cybersecurity in the ICS world.
Absolutely.
It's not just about stopping hackers.
Right.
It's about stopping people from actually getting their hands on critical equipment.
Exactly. And just like with logical access,
Oh.
we use a layered approach.
Right.
It starts with the basics, things like fences, locks, and security cameras.
Mm-hmm.
But it can also involve more sophisticated technologies like biometric scanners for access control
Wow.
or vibration sensors
Oh, okay.
that can detect if someone is tampering with equipment.
So it's about making it as difficult as possible for someone to physically get into those sensitive areas.
Right.
But I'm curious, do you ever have to worry about insider threats?
Oh, all the time.
Yeah.
I mean, someone who already has legitimate access but might use it for malicious purposes, that's a huge concern.
Yeah?
Think about disgruntled employees, corporate espionage. It definitely happens.
Sure.
That's why background checks,
Yeah.
security awareness training, and strict access control policies are so critical.
It's that human element again, isn't it?
Yeah.
Technology can only do so much.
Absolutely.
You need to address the human factor as well.
Absolutely. And that brings us to securing individual components.
Okay.
Basically making sure each device within the ICS is locked down tight.
Right, because if each individual component is secure,
Yeah.
then the overall system is stronger. Right.
That's the idea.
Kind of like how a chain is only as strong as its weakest link.
Exactly. So we talked about patch management earlier.
Right.
Just like with your computer or smartphone, those ICS devices need regular updates to fix vulnerabilities. We also harden the devices by disabling any unnecessary services,
Okay.
changing default passwords, and really locking down who has access to what.
So you're making sure that each individual piece of the puzzle
Yeah,
is as secure as possible.
exactly. And then we have some really cool tools
Okay.
like security information and event management systems, or SIEMs,
Okay.
which collect and analyze log data from all those devices.
So this is getting into the big data
It
type of
is.
things.
Yes.
I imagine with all those devices generating logs,
Right.
you need a way to make sense of it all.
Right. SIEMs can sift through mountains of data looking for those needles in the haystack
Okay.
that might indicate a security incident.
Wow.
They can help us identify patterns, spot anomalies,
Okay.
and even automate some of our responses.
So it's like having a central nervous system for your security,
I like that analogy.
pulling in information from all over the network
Yeah.
and giving you a more comprehensive view.
And of course, we can't forget about good old-fashioned endpoint protection.
You mean like antivirus software?
Exactly. It's not just for your laptop anymore.
Right.
We need that same level of protection on those ICS devices, especially as they become more interconnected,
Yeah.
exposed to the internet.
Okay, that makes sense.
Yeah.
Moving on, let's talk about protecting against data changes.
Okay.
we talk about how crucial data integrity is in an ICS environment.
Right.
What are some of the techniques used to make sure the data hasn't been tampered with?
Well, one of the most powerful tools we have is encryption.
Right.
It scrambles data so that only authorized users with the correct key can read it. This helps protect data both in transit and at rest.
So even if someone intercepts the data, it's just gibberish to them?
Right.
Unless they have that key.
Exactly.
I like it. What else?
We also use digital signatures.
Okay.
It's like an electronic fingerprint
Okay.
that verifies the authenticity and integrity of the data. It can prove that a message came from the source it claims to have come from.
Right.
And that it hasn't been modified in any way.
So if I send you a message with a digital signature,
Right.
you know for sure it was really me who sent it.
Right.
And that no one messed with the contents along the way.
Exactly. And it's incredibly difficult to forge a digital signature, making them a powerful tool for ensuring data integrity in ICS.
Okay, so we're using encryption to protect the data itself.
Right.
And digital signatures to verify its authenticity.
Exactly.
What happens if, despite all of this,
Yeah.
something still goes wrong?
Yeah.
Like, what if there's a hardware failure?
Right.
Or some other kind of disaster
Yeah.
that causes data loss?
That's where data backup and recovery procedures come in.
Okay.
No system is perfect. Things can and do go wrong.
Right.
Having a reliable backup and recovery plan is like having an insurance policy
Right.
for your data.
So even if the worst happens,
Yeah.
you can restore the system to a known good state.
Yes. Exactly. Which brings us to another key objective. Designing for redundancy.
Ah, redundancy.
Right.
We talked about this earlier, the idea of having backup systems in place.
Yes.
So that if one component fails, the whole system doesn't come crashing down.
Right.
Can you give us some examples of how this works in practice?
Sure. One common approach is redundant hardware.
Okay.
Imagine having backup servers, network devices,
Mm-hmm.
even power supplies, all standing by, ready to take over if the primary component fails.
So it's like having a spare engine on an airplane.
That's a great analogy.
If one fails, you can still fly on the other one.
We can also have redundant communication paths.
Okay.
So if one network connection goes down, there's an alternate route for data to travel.
Mm-hmm.
Think of it like having multiple roads leading to the same destination if one is blocked.
Right.
You can take a detour.
Okay, that's starting to paint a picture of how this works.
Good.
Are there any other examples you can share?
Sure. There's the idea of geographically dispersed systems, where critical components are located in different physical locations.
Right.
This helps protect against things like natural disasters or localized power outages. If one site goes down, another one can pick up the slack.
So it's like having multiple data centers spread across the country.
Right.
If one gets hit by a hurricane
Exactly.
or an earthquake, the others can still operate.
Right.
That's brilliant. Are there any other ways to build in redundancy?
Absolutely. We can also create fault-tolerant systems,
Okay.
which are designed to keep running even if some parts of the system fail.
Wow.
This often involves using specialized hardware and software that can detect and compensate for errors without any human intervention.
It's like a self-healing system,
Right.
able to route around problems or switch to backup components automatically.
You got it. And that level of resilience is incredibly important for ICS,
Yeah.
where downtime can have such serious consequences.
Okay, so we've talked about firewalls,
We have...
intrusion detection, multi-factor authentication, physical security measures,
Yes.
hardening individual components, data encryption, digital signatures, data backups, and all sorts of redundancy.
That's a lot.
It seems like we've covered just about every angle of ICS security.
I think so.
Is there anything we've missed?
Oh, we can't wrap up this deep dive without talking about incident response planning. Remember, we've been talking a lot about prevention, but no system is foolproof.
Right.
So what happens if, despite our best efforts, a security incident does occur?
Right. It's like that fire drill we talked about earlier.
Exactly.
You need to know what to do when the alarm goes off.
Right.
Not just how to prevent the fire in the first place.
Exactly. And having a solid incident response plan can make all the difference.
Welcome back to our deep dive into industrial control system security. It's been quite a journey so far, hasn't it? We've gone from the basics like what ICS is and why it matters,
Yeah.
to exploring all sorts of technical details and security measures.
It's been a whirlwind tour. For sure, but I think it's important to step back for a moment and think about the bigger picture.
Okay.
You know, we've talked about the what and the how of securing ICS,
Right.
but now I'd love to hear your thoughts on the the so what.
Okay.
What are the broader implications of all this?
That's a great point. We've gotten pretty deep into the weeds here.
We have.
But I think it's crucial to connect this back to the real world
Yeah,
and understand why it matters for everyday people, not just cybersecurity experts.
exactly. For a long time, ICS security was considered a niche concern,
Right.
something that only engineers and IT specialists
Hmm.
really needed to worry about. But that's simply not the case anymore.
Yeah, I'm starting to see that. It's not just about protecting data or preventing some abstract cyber attack.
Right.
It's about protecting the systems that literally keep our society functioning.
Precisely. Think about the cascading effects of a major power outage,
Yeah.
a disruption to water treatment facilities, or a cyber attack on transportation systems.
Hmm.
These aren't just inconveniences. They can
Right.
have devastating consequences
Yeah.
for people's lives, the economy, even national security.
Yeah, it's a bit unsettling when you put it like that.
It is.
It makes those real-world attacks we talked about earlier,
Yeah.
like the water facility in Florida
Right.
and the pipeline incident,
Yeah.
even more concerning.
Those incidents were stark reminders that these threats aren't theoretical or some distant future problem.
Right.
They're happening right now.
Right now.
And as our world becomes even more interconnected and reliant on automation, the stakes just keep getting higher.
I have to admit, it all feels a bit overwhelming.
I understand.
It's like this massive, complex problem, and I'm just one person.
Yeah.
What can I actually do about it?
I understand that feeling, but here's the thing.
Okay.
While the challenges are significant,
Mm.
it doesn't mean we're powerless. There are things we can all do, both individually and collectively, to make a difference.
Okay, I'm all ears. Where do we even begin?
First and foremost, we need to raise awareness.
Okay.
The more people who understand the importance of ICS security and the potential consequences of failure, the more likely we are to see action and investment in this area.
So it's about having conversations like this one.
Exactly.
Educating ourselves and others.
Yes.
And making sure our policymakers
Yes.
understand that this is a serious issue.
Absolutely. We also need to focus on workforce development.
All right.
We need more skilled professionals who understand the unique challenges
Right.
of ICS security.
That makes sense. We need people who can design, implement, and maintain these systems securely.
And that means investing in education and training programs,
Mhm.
encouraging collaboration between industry and academia,
Yeah.
and creating pathways for people to enter this field.
So awareness and workforce development are crucial.
They are.
What else can we do to kind of move the needle on ICS security?
Stronger regulations and standards are also essential.
What?
Governments have a role to play in setting clear guidelines and requirements,
Right.
particularly for critical infrastructure.
Because right now it seems like there's a lot of variation in terms of security practices
There is.
across different industries and organizations.
That's true.
Yeah.
And we need to incentivize collaboration and information sharing between organizations.
Right.
We can learn so much from each other's experiences, both successes and failures.
It's like that saying, a rising tide lifts all boats.
Exactly.
If we work together and share knowledge,
Yeah.
we can all improve our security posture.
Precisely.
Yeah.
And ultimately, I think it comes down to building a culture of security.
Okay.
We need everyone to understand their role in protecting these critical systems,
Right.
from the engineers who design them to the operators who run them to the everyday people who rely on them.
It goes back to that idea that ICS security is everyone's responsibility.
It is.
It's not just about the technology. It's about the people, the processes, and the awareness.
Exactly. And that's a powerful message to leave with our listener.
It is.
In a world that's becoming increasingly automated and interconnected,
Mm-hmm.
we all have a stake in making sure those systems are secure and resilient.
I feel like I've learned so much from this deep dive. It's opened my eyes to a whole new world of risks and challenges,
Yeah.
but also to the incredible work being done to protect these vital systems.
It's been my pleasure to explore this topic with you,
Likewise.
and I hope it sparked some curiosity.
Yeah.
And maybe even inspired our listener to learn more and get involved.
To our listener, remember, even small actions can make a difference. Stay informed, engage in conversations about ICS security,
Absolutely.
and demand better security practices from the organizations you interact with. The future of our critical infrastructure depends on it. Thanks for joining us on this deep dive.